Learn how to migrate an existing ASP.NET Core MVC application that's sitting in production to Blazor WebAssembly. What are the benefits? What are the trade-offs? Join me as we uncover in every detail with insights and analysis step by step. Okay, so let's just add a bit of context to what it is that we're trying to achieve here. The solution that we're dealing with, the one that we want to migrate to Blazor WebAssembly, is an ASP.NET Core MVC web application. Now you can see here there's a couple of class libraries, and then we've actually got the web application itself. And if we actually have a quick look at the project file, we can see here that it's already targeting .NET 6. So it's already benefiting from some of the rendering capabilities that were added in .NET 6 to keep this really efficient and compact. And that's really important for this type of website because this is predominantly a Brochureware application. And as part of a Brochureware application, you've got a number of different pages. You've got navigation and things like SEO and fast loading of assets such as CSS and JavaScript. They all play quite a large part in having a successful web application. And this particular application is live, it's in production, it advertises Blazor and .NET services. So it's key to this particular business in order to function well, to render efficiently, and for the user to have a nice experience. Okay, so at this point, let's just transition to actually running this web application. Let's have a look and see what it looks like so we know actually what we're dealing with. So essentially this is the MVC, the ASP.NET Core application. You can see it's a kind of typical website. It's got navigation, we've got a number of different pages, sub pages, and all the typical elements that you would find in a site. If we just focus on the home page though, just for the time being, we can see that the navigation element is at the top. We've got some headings, we've got some call to action sections and some page sections as we kind of navigate down. We've got a bit of JavaScript and CSS clearly going on here, so that's something that we'll need to extract, but we'll just kind of move down the page. It looks like it's fairly well laid out in terms of these page regions. If we now just jump back to the code, we can actually just have a quick look at the way that the project is organized. So just following the MVC pattern, we've got the models folder, the M, we've got the views here, and then we've got the controllers as well. So these are our different endpoints that you can see here, kind of broken down by the main areas of the site. And then if we just kind of drill down into the views a little bit, we can see that there are a number of different subfolders grouping the areas of the site, and then we've got a number of partial and shared views which are reusable components, such as things like the footer, the main layout itself, things like testimonials and other elements as well. So we can start to see how we might migrate some of these views into components within the Blazor project. And we know that in Blazor everything is a component, whether it be a layout, whether it be a page, or whether it be a smaller piece of functionality. Everything is essentially a component. Okay, so let's just look at some of the benefits and trade-offs, some considerations when it comes to Blazor WebAssembly. Now, it runs on the client, so this means that there's a lot less load on the server, which can be offloaded to the client, which in this case is the web browser. And this could lead to some significant cost savings and potentially improve scalability as well. We've got the fact that the application is deployed as static files. So a Blazor WebAssembly app are just static files, DLLs and assets, and they can essentially be deployed anywhere that static hosting is available. And if you think about it, this opens up an awful lot of options previously unavailable, because we could use services such as Azure Blob Storage to actually serve our application. There's no need for a specific web server as such, because the WebAssembly files are running in the browser. We could also utilize Azure Static Web Apps, GitHub pages, for example, Amazon Web Services, S3 buckets, and the list really kind of goes on. They're all options for hosting standalone Blazor WebAssembly apps, and the cost of deploying static files is generally a lot less to needing to actually stand up a hosted server from any of the leading cloud providers. We've also got this point about working offline. Blazor runs in the browser sandbox entirely, so there's no need for this kind of constant connection between the browser and a server, which makes Blazor WebAssembly applications a lot more tolerant to fluctuating network availability. There's the point about shared code here. So one of the benefits really of just Blazor in general, but it certainly applies to Blazor WebAssembly, is that you can use C# everywhere. You can use the same C# classes and objects on your client as well as on the server. So there's not this same issue that arises with having to keep code in sync or duplication of code, because you can actually share it, particularly around things like models and services between the client and the server. So looking at some of the trade-offs, we've got this kind of payload stroke load time. If we compare a Blazor WebAssembly application to, say, a JavaScript and HTML based only app, then there is a significant increase in size for a Blazor WebAssembly application on the initial download. Blazor apps can be significantly bigger, but this is just a one-time cost. Once it's been downloaded for the first time, the runtime is smart enough to be able to reload that application from the browser cache and give the user that really kind of snappy experience. But the knock-on effect is that the initial load time for the user can feel longer than a typical JavaScript based application, and we can solve that with a number of approaches, one of them being some server-side rendering, which doesn't allow you to interact with the application, but it does give the user something to look at and to feel while those DLLs are downloading. And also we've got things like progress bars and other options as well. But during that state, while we go through that initial load, we're not able to interact with the page. So It's just something to bear in mind, but by architecting the application well, we can try and keep that payload size down, and also strides are being made with every single Blazor version to ensure that the runtime and initial render time is just being reduced with every release. There's also the point here about the restricted runtime. And this really is just a case where typically using .NET we have access to everything on a user's machine, but a .NET Blazor WebAssembly application is running in the same browser sandbox as a JavaScript application, so there is limited access to certain user resources, for example the user's file system. And then we come to this final point about code security. So just as with JavaScript applications, your code is downloaded and runs in the browser. So the user has access to your application's DLLs. This means that they could be unpacked, reverse engineered and viewed. So we really need to be careful about what we put into those DLLs in a Blazor WebAssembly application. So they shouldn't contain things like intellectual property or any secrets that are destined and required by the server. Instead, we should put any valuable code wrapped and protected by an API and have that run on the server. Well, I hope you've enjoyed this first part and are looking forward to our journey together. So what will we cover next? Oh, and do let me know if you have any other topics that you'd like me to cover or see in this migration series. And don't forget to like and subscribe to the channel and jam that notification bell to get notified as soon as new content gets added. In part 2, we'll nail down a hosting solution, code repo, and create our initial Blazor WebAssembly application, with DevOps enabling a streamlined workflow lighting up our ongoing development. Thanks for watching.